not only atoms, there are many molecules that also forms covalent bond, and it forms covalent compounds. For instance, we can see one example, HCl, hydrochloric acid, or like a hydrogen chloride. Hydrochloric acid, it is a liquid mixture of HCl gas. Okay, we can see HCl. So hydrogen, it is having one electron. Chlorine, atomic number 17, so it is having 287. So this one electron, it is going to donate to chlorine, so that chlorine changes to Cl minus, sorry, yeah, let's see how it will be changing. Yeah, of course, chlorine, it is going to develop a partial negative charge. So I can draw like this. This is a hydrogen atom, and yeah, this is a chlorine atom. So this outer 7 electrons, I will check it. 1, 2, 3, 4, 5, 6, 7. 7th electron shall come here. Now for 1 electron from hydrogen, this is hydrogen. 1 electron from hydrogen is supposed to come here. Okay, so this is going to, yeah, so this is nucleus, by the way. This is again nucleus. So now we shall see this is hydrogen atom. This is chlorine. Now hydrogen is having 2 electrons, right? 2 electrons for hydrogen. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 electron is for chlorine. So hydrogen is happy because hydrogen is having only one shell. It got only 1 electron in the outermost shell, and 2 electron in the outermost shell. And chlorine is also happy because chlorine got 8 electrons in the outermost shell, right? Now next example, we shall take the example of water. Okay, so so this is hydrogen, and this is hydrogen. This is oxygen. So oxygen, as you are very clear, it is having 8 is the electronic configuration. So 2, 6. So 1, 2, 3, 4, 5. The 6th electron, let it come here. So again 1, 2, 3, 4, 5, 6th electron, let it come here. Hydrogen is having only 1 electron, right? So that the hydrogen electrons, it is supposed to, let's take the example of water. So see, in water, 1 oxygen, it is bound to 2 hydrogen atoms. So this is H2O. The formula is H2O. Let's see how it is going to come. See, this is oxygen, it is having 8 is the atomic number. So 2, 6, this is the electronic configuration. So 6 electrons will be there in the outermost shell. So hydrogen, it is having only 1 electron. Only 1 electron is there. Hydrogen is not so proud of having many electrons. So now 1, 2, this is oxygen, this is hydrogen. 3, 4, 5, 6. Now 1 electron from hydrogen, let it come here. Let it come here. Now let's see how many electrons are there with oxygen. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there with the hydrogen. 2 electrons are there with the oxygen. 2 electrons are there with the oxygen. Okay. So this is the reality. So now hydrogen is having 8 electrons. 8 electrons, and oxygen is having, oxygen is having 8 electrons. Hydrogen is having 2 electrons. And the next hydrogen is also having 2 electrons. Okay, and yeah, so now this is the case with the water molecule. But here you should know one thing. See, there is 2 electron here which is not bonded to anything. This is also 2 electron. This is also not bonded to anything. That means 2 pair of non-bonding electrons are also there with the water molecule. So if I write in a proper way, this is H2O. And we can write in this way, or in some representations they will write in this way, or anyway, which is whichever is convenient for you to write. Okay, you can write it. Okay. Now next example is methane. So methane. So methane, carbon, it is bonded to 4 hydrogen atoms. So now carbon, it is having the atomic number 6. So it is 2, 4. So 4 electrons are there with outermost shell. Yeah, so if I count it, so I can write, yeah, so this is carbon, and for hydrogen, as you are aware, it is only 1 electron. So you can check it. So I will write in this way: 1, 2, 3, 4. So each carbon electrons I am going to fill it here: 1, 2, 3, 4. So each hydrogen electrons also I am going to fill it here. Okay. So here each carbon atom, now it is 1, 2, 3, 4, 5, 6, 7, 8. Carbon is having 8 electrons are there with the carbon. Hydrogen, it is having 2 electrons. 1, 2, 2, 2. So 2 electrons are there with the hydrogen. 2 electrons are there with the nitrogen. 2 electrons are there with the hydrogen. Okay. So this is the case. So hydrogen is having 2 electrons. Carbon is having 2, 2, 2, 2. So 2 plus 2 plus 2. So it is going to have 8 electrons. So this is how the methane molecules are coming. As you are aware, it is a gas, and it is actually most of the covalent compounds, it is gas. See, CH4 is a gas, and yeah, now HCl is also a gas. Okay, yeah. Here let's see how the methane molecule it is what shape and what things it is going to attain. See, the methane molecule, it is going to have a tetrahedral shape. See, it appears something like this. Okay, so it will be in the tetrahedral shape, CH. So it is actually, so it occupies in the 4 corners of a tetrahedron. Okay, so this is how the molecule attain. So this is in the form of a tetrahedron, because all carbon atoms, it occupies 1 carbon atom, it will be here, next one here, next one here, next one here. So it is in the form of a tetrahedron. On the other hand, if you check water molecules I already told you. So like oxygen, it is going to have a lone pair, next lone pair, and next 2 hydrogen atoms are there, right? So this occurs in the form of a bent shape, or like you can say V-shaped molecules. Do you know the reason? Because this bond pair of electrons are having negatively charged particles, right? So this will be repelling each other. Due to the repulsion, so the bond pair here, this also going to experience some repulsion. So instead of becoming linear, slight bend it will come, and it is going to form a V-shaped molecule, victory-shaped molecule. So this is going to have the bond angle 109 degree. So here it is going to have 104 degree. Here it is going to have the bond angle, it is going to have something around 1095. Okay, so this is the bond angle it is going to have. Yeah. Let us take a little more examples of covalent compounds. Now ammonia. See, ammonia, its a molecular formula is NH3. So okay, so one nitrogen it is going to bind with 3 hydrogen atoms. Okay, so nitrogen its atomic number is 7. So it is 2, 5. Hydrogen, its atomic number is 1. So there is only 1 electron. So now, so here nitrogen. So this is hydrogen. This is hydrogen. Again, this is also hydrogen atoms. So this is 5 electrons are there, right? 1, 2, 3. Now the next one is for hydrogen. It is 1, 2, 3. Now remaining 2 electrons of nitrogen atom. So that is going to occupy here. Sorry. Okay, that is going to occupy here. And here, what you can understand here is, see, this is a lone pair of electrons. Okay, so nitrogen atom, now it is going to have 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there with the nitrogen atom. For hydrogen atoms, 2 electrons, 2 electrons, 2 electrons. Okay, so every hydrogen it is happy because it got 2 electrons in the outermost shell. Nitrogen atoms, it is already got 8 electrons in the outermost shell with 1 lone pair of electrons. Okay, and it is going to occupy the geometry of a pyramid. Pyramid is something like this geometry it is supposed to come. So nitrogen, so this way it is supposed to come. Nitrogen is going to have this geometry, so 1 2 3, so this is going to have a pyramid geometry. Okay, now another one is methanol, or else I can say carbon dioxide. See, carbon, its atomic number is how much? Carbon is having 6 is atomic number, so 2 4. So oxygen, it is having 2 6, right? Now I will say, let's see the electronic configuration. Let's see how the carbon dioxide it comes. So this is carbon, and this is oxygen, carbon, double bond oxygen, double bond oxygen. I will tell you why it has come in that way. So 6 electrons of oxygen are there. 1 2 3 4 5 6. Now for carbon it is 1 2 3 4 5 6, and for carbon it is having 4 electrons, right? So 1 2 3 4. That means now you can count for carbon 1 2 3 4 5 6 1 2 3 4 5 6 7 8. 8 electrons are there with the carbon, so it is happy and it does not have any issue. For oxygen 1 2 3 4 5 6 7 8, 8 electrons are there with oxygen. Again 8 electrons are there with the next oxygen also. So it is going to have a double bond because 2 pairs of electrons are there. See, with each carbon oxygen bond. So this is going to form a double bond. Okay. Double bond. Okay. Now what you can know, see, due to the formation of this double bond, like it is going to have a, this is having a double bond formation, and what I can say, this is nothing but the carbon dioxide molecule, and as I have shown you, carbon dioxide is a linear shaped molecule. Linear is a straight line. So the bond angle between carbon and oxygen, it is going to be 180 degree. Let's see the example of ethene. So it is actually C2, its molecular formula C2H4. If I write properly, it is each carbon, it is bonded to 3, so it is 2 hydrogen atoms with a double bond. So this way it is supposed to come. Let's see how its bonding is happening. So this is one carbon, this is next carbon. So carbon is having 4 electrons, which you are very familiar. So this is again one hydrogen, next hydrogen, next hydrogen, and next hydrogen. Okay. So now here carbon is, as I told you, it is having 4 electrons. So 1 electron it will come here, next one, and next one, next one. So for this carbon, this is a carbon atom, hydrogen. This is again hydrogen. This is again hydrogen. This is again hydrogen. So yeah, for here the carbon atom electrons from here 1 2, so sorry, I will draw using this. So 1 2 3 4. Okay. Now what you can know is, see this 2 electron pairs, it is in between 2 carbon atoms, so it is going to form a double bond. So here it is hydrogen, here it is hydrogen, here it is hydrogen, here it is hydrogen. So okay. Now so this hydrogen atoms, its electron, it is going to occupy here. It is occupy here, occupy here, and it's going to occupy here. Okay. So this is how the electronic configuration, arrangement of molecules it comes, and it is mostly in the form of these both carbon atoms. This carbon atom also and this carbon atom also, both is in the form of a tetrahedron. Okay, it occupies in the form of a tetrahedron with a not tetrahedron, triangular planar. Okay, triangular planar. I can show you the the video, or something like this. It is something. It is actually A. Let it be B and B, B. So it is in the form of a triangular planar, it is in the form of a circular triangular planar, it is supposed to come. So now next molecule is methanol. Let's see how the methanol it is going to come. See, for instance, so CH3 OH. So this is methanol. So let's I shall draw the structure of carbon. So 1, 2, 3, and now this is oxygen. This oxygen is going to bind with the hydrogen. So okay. So carbon is having 4 electrons in the outermost shell. 1, 2, 3, 4. So here this is going to have 1, 2, 3, 4. This is yeah, these are actually hydrogens. So now you can understand, actually this carbon, it is 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons are with the carbon atoms. Okay. 2 electrons are there with the hydrogen atoms. Okay, now we will go into this oxygen is having 1, 2, 3, 4, 5, 6. Yeah. And this 7th one, it is supposed to come here. And for 8th one, it is supposed to come here. Okay, I will draw this a little bigger. Okay. And yeah. So this oxygen, this is actually, this is oxygen. And this is again hydrogen, right? So for hydrogen, you know, like this electron, it is supposed to come here. So this is hydrogen again, this is oxygen. Oxygen, now you can count how many electrons are there. 1, 2, 3, 5. 1, 2, 3, 4, 5, 6, 7, 8. No, sorry. Here it is supposed to be. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. This is also having 8 electrons. And this hydrogen is also having 2 electrons. So everywhere, you know, like this is, I mean, like the valency it got fulfilled. And it does not have any instability since all valencies are fulfilled. Okay.